Welcome back. In this video, we are going to see the different traversal methods we use for the graph. Uh, I hope you remember we have seen different traversal methods for trees. Same way, we are going to see different techniques to visit every node in a given graph. So normally we use two different traversal algorithms. One is we call it as the breadth first search or BFS, and second one is DFS, which is depth first search. So the basic difference is BFS uses a queue as auxiliary data structure, whereas DFS uses a stack. Apart from this, there are a few more differences, but in terms of the data structures, the first one uses queue and the second one uses a stack. So let us see how this BFS works. So we begin at the root node and explore all the neighboring nodes. You can start with any node, but normally we start with the root, and for the given root or the root, you're going to find all the neighboring nodes. For each those nearest node, what it does is which is going to explore their unexplored neighbors. Let me make it clear. First, you are going to begin with root. For the root, you are going to find the neighbors. Again, for those neighbors, you are going to find unexplored neighbors, until it finds the goal. So look at the tree. Look at the graph which is on the screen. So what you should make sure that you have to guarantee that every node in a graph is processed, every node in the graph is visited, and also make sure that every node is processed only once. These things you have to make sure. So let us see the algorithm in detail. So the first step is you are going to take a queue as I told. So this BFS uses a queue as data structure, and the size of the queue is based on the number of vertices in the graph. Next, you're going to select any vertex as starting point, which can be root or some other node. Visit that vertex and insert it into the queue. You're going to start from the root, and the root node you're going to insert into the queue. So visit all adjacent vertices of the vertex which is friend of the queue. So already I have inserted the root into the queue. So initially there will be a queue with a single vertex, and for that vertex, for that root, you are going to visit all the nodes. So you are going to visit all the adjacent vertices of vertex which is at front of the queue, which is not visited, and insert them into the queue. So when there is no more vertex to be visited, you are going to delete that vertex from the queue. First thing is you have to insert into the queue, visit all the nodes which is adjacent to that, insert them into the queue, and once you find that there is or there are no more vertex which is adjacent to that, you can delete that vertex from the queue. Next, you have to repeat this until the queue becomes empty. After that, you can either NQ or DQ order gives you the BFS. Sometimes which is going to NQ is going to give you the BFS order, or DQ is going to give you the BFS order. So let us see how does it work. So you can see a graph with 7 vertex. So we are going to select any node as the root or the start vertex. So we are going to select A as the start vertex. So you can see the change in color. So A is the starting vertex. So we have to insert this A into the queue. Next, visit all the vertex or vertices which is adjacent to A. So I can find D. So I've inserted D into this. Then there is B which is adjacent to this. I'll insert B, and there is E which is this also adjacent to this. So we have inserted three nodes. So we are going to insert newly visited vertices into the queue, and now what happens? There is no more node which is adjacent to A. So what I should do? I should delete this A from the queue. So here it is no A. You have to continue with this. Now who is at front of the queue? Front of the queue was D. For the D, you have to find the adjacent vertices. So when I take D, so D has got a single vertex E, but E has already inserted. So I need not do it. So visit all adjacent vertices of D which are not visited. So there is no node which is not visited. So what I do, I delete D from the queue. Next, visit all adjacent vertices of E. Next one is E. If I take E, he has got two vertices which is adjacent, and they are C and F. So I'll insert C and F into the queue. Now I should visit all adjacent vertices of B which is in the front of the queue. So when I visit B, I can find there are no vertices which is adjacent to this, because this is already visited. All the nodes are already visited. Next, how to find which node is at front of the queue, which is C. So visit all the nodes which is adjacent to C, and adjacent to C we have F and G. So I'll insert F and G into the queue and delete C from the queue. Next, friend of the queue is F, and F has got no node which is not visited. There is no vertex. So what I should do? I should delete F from the queue. Continue with this. There is a single node in the queue which is G. Find out the nodes which are not visited, and I can say that there is no vertex which is not visited. So I'm going to take out G from the queue. So when I take out the last node from the queue, I'll be getting this as my BFS, which is going to be A, B, D, E, F, C, and G. So this is going to give you the BFS traversal. This is nothing but the BFS traversal order.